Okay, in this video, we're going to talk about graphing quadratic equations and inequalities, or graphing parabolas, and in the three different forms. We have our standard form, our intercept form, and our vertex form. We're going to show you all three of them and some tips on how to graph in all three forms. We're going to start out with our vertex form. And in our vertex form, it's really easy to identify transformations. So what we're going to do in this form is we're going to graph our normal y equals x squared parabola. Now I do want to remind you there will always be a 1, 3, 5, 7 pattern, that arithmetic sequence. We're going to graph our normal x squared, and again that 1 up 1 over 1, up 3 over 1, up 5 over 1. There's going to be your normal parabola. And again you see that 1, 3, 5, 7. Now this parabola has been moved to the right 2 and down 4, so we're going to take every one of these points and move it right 2, 1, 2, 3, and down 4. There's your new vertex, and you can actually just do the 1, 3, 5, 7 pattern from that. 1, 2, 3, 1, 2, 3, and that's going to be the graph of that parabola. Now, if something's been stretched or compressed, we know it's not going to follow that pattern. The second one also in vertex form, so we're going to take all of our points, we're going to move them left 4 and up 1. So our vertex is going to be moved left 4, 1, 2, 3, 4, and up 1. Now, instead of following the 1, 3, 5, 7, notice this one has a stretch and a flip out front. So instead of 1, 3, 5, we're going to multiply everything by -3, and we have -3, -9, -15, and that's the pattern we're going to follow. So instead of over 1 and up 1, we're going to go over 1 and down 1, 2, 3, and then mirror image it on the other side. And we could do 9 if we had enough room, but that's going to be your parabola. Okay, if we're in, this is going to be our intercept form. The easiest way, no, don't get thrown off by the less than sign. That just tells us we're going to shade it at the end. These two values tells us what our intercepts are going to be. If we set this thing equal to 0, that tells us we're going to have an intercept at 1 through 3, 4, and an intercept at 6. Okay? And right in between those two values, if we average them, and we already know what the average is, it's going to be 5, that's where that vertex is going to be located. So what we're going to do is, once we figure out where that vertex is going to be located, we're going to plug that value in to this whole thing, and we're going to get our vertex. So plugging in 5 gives us 5 times 1 times -1, which is -5. So 5, -5, 1, 2, 3, 4, -5 is going to be your vertex. You can connect your dots, or in this case, we're going to dot our parabola. And the reason we're going to dot it is because it says is less than. It doesn't have an or equal to. And then we're going to shade everything below that parabola. I'm just going to shade a little bit, just give you the idea. Just don't shade anything inside the parabola. And that's it. And again, the reason we shade below is because of the less than. Okay, next up, we're going to graph another one of those. So this one, we have our intercepts at 2 and 3. So there and there. So right in the middle at 2.5, that's where your vertex is going to be. So we're going to plug in 2.5 in for all of our x's. So we have -1 times 2.5 minus 2, and 2.5 minus 3, which is -1/2. Multiply all that together, and it gives you 1/4. So at 2.5 comma 1/4, which is going to be somewhere right around in there, is going to be where your vertex is. So your parabola is going to look something to that effect. Next up, what if it's in standard form? Well, the first thing you're going to do in this form, you can factor it, and you can get it in the other forms if you'd like to. You can complete the square and get it in the other form. That might be a little bit easier, but I'm showing you if you want to go straight to the graph from this, you can plug in points. But what I always like to do is find the vertex, -b over 2a, to where a is 1, b is -6, and c is 5. So -b is -6. 2 times 1 is 2. So your vertex is going to be located at 3. Now, plugging that 3 value in again to find the actual vertex, this is just the x value. To plug that in, I always plug it into the 3 spots. You have 3 different parts of this equation. You have 3 to the second power, which is 9, minus 6 times 3, which is 18, and then you have your plus 5. Adding your positives together gives you 9 and 5 is 14. Subtract that 18 gives you a -4. So 3 comma -4 is your vertex. 1, 2, 3, 1, 2, 3, 4. Now, again, let's go back to that 1, 3, 5, 7 pattern. If there is no number in front of x squared, then this is not stretched. So what you can actually do is use that 1, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, since we have room, and that's going to be your parabola. Again, if it's stretched, if there's a number in front of that x squared, it works the exact same thing, exact same way as the a value here. If there is a number in front of the x there, works the exact same way. If there is a number out here, that's going to be your stretch value. And you can, again, you could have also factored that, and you've got x minus 5 and x minus 1, and you can see those intercepts there. All right, the last one. Again, this one has been stretched. So we're going to do our negative b over 2 times 2 is 4. So we have a vertex value at negative 2, comma something. In order to find out the something, we're going to plug it in. So this will be 2 times 4, which is 8. This will be 8 times negative 2, which is negative 16. And then we're adding 3. Our positive values are 11. We subtract 16, it gives us negative 5. So our vertex is actually at negative 2, negative 1, 2, 3, 4, 5. And again, if you want to use your pattern on this, the 1, 3, 5 pattern, this one's being multiplied by 2, so it'll be 2, 6, 10 instead. So from that dot, we're going to use up 2 over 1, up 6, 1, 2, 3, 4, 5, 6, and over 1. And that's going to be plenty of points. Since it's greater than or equal to, we're going to actually connect our dots because of the or equal to. Because of the greater than, we're shading everything above, and that's going to be the graph of that parabola.